We're going to look at functions. This is Unit 4 from the Math 8 curriculum. And Unit 4 talks about the difference between relations and functions. When we talk about a relation in math, all we're talking about is an ordered pair. So if you have an ordered pair, an XY, then you have a relation. And you guys learned some words to represent the X and the Y. The X can be called the domain. It's the input in a function, and it's the independent variable when we're writing an equation or graphing. And the Y is known as the range. It's the output of a function, and it's the dependent variable when you're working with an equation. The difference between a function and a relation is that a function, no X is repeated. And the true definition for a function says that each X has exactly one Y. So what we say for a function is that all the X's are different. So if it is a function, all the X variables, all the numbers in the domain, all the input variables, all the independent variables, all X's are different. And that is what will make a relation a function. So if you're looking at ordered pairs, and I have some ordered pairs right here, what you want to do is check the X's. You want to make sure that all of the X's are different. Those are the numbers in the domain, and all the X's need to be different. So if you can see here, we have a duplicate. 3 is used in the X position twice. So this one is not a function. I have right here a t-table, and we want to make sure that all the X's are different. When you go through, you just need to look at the X column on a t-table and make sure that all the X's are different. And if they are, then it is a function. This is a mapping. And a mapping usually has ovals. The first one is the X, the second oval represents the Y, and the numbers in the oval are the X's or the Y's, depending on which one they're in. And we connect the X and Y numbers with arrows. Right now, this is a function because each X is connected to only one Y. If I draw this arrow right here, now it is no longer a function because I'm using 3 twice. I connected 3 with 8 and I connected 3 with 2. So this one now is not a function. We can also look at the vertical line test when we are trying to decide if a graph is a function. The vertical line test is pretty simple. You're going to draw some vertical lines and test the graph to see if the function is in fact a function or just a relation. So when you get a graph, and I already made, this is the X and the Y axis, so here is our line. I'm going to draw a vertical line, and what I'm doing is I'm checking to make sure that I only hit my graph one time. So every vertical line only hits once. And if you think about it, I could number all these vertical lines, and those numbers would represent the X. So all of these are different, so this is a function. So the vertical line test is a way to test if a graph is a function. If we look at this one, when I draw a vertical line, I'm hitting the graph in 3 places. This one is not a function. When I look at this one, I draw a vertical line, it hits it once. I draw a vertical line, it hits it once. I draw a vertical line, it hits it once. You get the idea. This one is a function. All of the X values are different. Also in this unit, we looked at linear functions. And a function is linear if it is a line. So first, to be a linear function, it has to be a function. And then the graph has to be a line. And if you look at the word linear, you see the word line. So linear means line. You guys also learned that the equation of a line is y equals mx plus b. So if you were to ask to look at an equation and decide if it's a linear function or not, you have to be able to write it as y equals mx plus b. So I have some examples right here. This first one, you can see the y equals mx plus b. So this is a linear function. When you look at this one, I can't write it as y equals mx plus b. There's no y. This is not a linear function. When I look at this one, it's close. It looks like I have y equals mx, but this exponent throws it off. So this one is not a linear function. Looking at this one, I have to be able to write it as y equals mx plus b. I can't have it divided by x, so this one is not a linear function. Looking at this one, y equals 9, I could write it as y equals mx plus b if I wrote it as y equals 0x plus b. So this one is a linear function. And our last one, 6x plus y equals 1. I could write this in the form y equals mx plus b. What I would need to do would be to subtract the 6x from both sides. When I do that, I will end up with y equals negative 6x plus 1, and that is the form y equals mx plus b. So this one is a linear function. Another way that you might be asked to determine if a function is linear is by looking at a table of values. The best way to do this is to look for a constant change. What that means is you need to go from number to number in the chart. To get from 2 to 1, I need to subtract 1. To get from 1 to 0, I need to subtract 1. To get from 0 to 2, I would need to add 2. To get from 2 to 1, I would subtract 1. This is not a linear function. There is not a constant change. Looking at this one, from here to here, you would add 3. From here to here, you would add 3. From here to here, we had to add 3. From here to here, we had to add 3. Now we need to come over and check our x column as well. From here to here, there's plus 2. There to there, we need to add 2. There to there is plus 2. And from 2 to 4 is plus 2. There's a constant change on both sides, so this one is linear. That sums up Unit 4 on functions.